Hi all, another quick video on electrical current, calculating currents, resistances and voltages. So here we have a circuit, 24 volts with a 35 ohm resistor, a 15 ohm resistor and a 30 ohm resistor. I have done this one in class so you might recognize it. Normally they're going to ask us to calculate the total resistance of the circuit, and then it will be current through one resistor, the energy, etc, etc. Really what we want to do is calculate the voltages and currents through each of these resistors, and that will allow us to finish off these questions. So first let's analyze. The current will come out here, and all the current will pass through this resistor, and then the current will split at this point and then rejoin at this point, and all the current pass through there. Okay, so and our voltage will have a voltage drop across this resistor, and because these two are in parallel, they will have the same voltage across those resistors, and those two voltages there, when added together, will equal our total voltage of 24 volts. And we'll be using Ohm's law, which V equals IR for the whole circuit and any parts of the circuit. So now let's jump in and start solving the problems. The total resistance. Well, the total resistance is based on these three resistors. We have a 35 ohm resistor, and that's in series with these two resistors, but these two are in parallel. So we first have to calculate the parallel resistance of these two and represent them as an imaginary resistor in series. So 1 over R parallel equals 1 over 15 plus 1 over 30. If we change that to 30, that will become 2, so it equals 2 over 30. Therefore, R parallel equals 30 over 2, which equals, I'll just jump back. 1 over 15 and 1 over 30 equals 3 over 30. That's better. So 30 over 3 equals 10 ohms. So we have an imaginary 10 ohm resistor in series with our 35. So our total resistance equals 35 plus 10, which equals 45 ohms. That's our total resistance, part 1. So now we want to calculate the current through the 15 ohm resistor. Well, to do that we need to calculate the voltage drop, because we want to calculate the current, so we need to know the voltage drop, because I will equal V over R. So what we'll do is, we've got enough information here now where we can calculate the voltage drop at this side, and then it will be whatever 24 minus that will equal the voltage drop across there, which will allow us to calculate the current. So working here, I equals V over R, and for the whole circuit we've got 24 divided by 45, and we'll equal that. 24 divided by 45 equals, so we've got 0.5333 amps going through there. So now we know what's happening here, we can calculate this voltage, because V equals IR, and this is V for the 35 ohm resistor. So I'll just put that in there. So we've got 0.533 amps times our 35 resistance, and that equals 18.667 volts. So now we want to find the current that's running through, the voltage here. So we've got 18.667 there, 24 minus 18.667 leaves us 5.333 here, and that gives us the voltage across the parallel resistors. So now we have the voltage, we have the resistance, we can calculate the current running through that. So I on the 15 ohm resistor will equal V over R, which equals 5.333 divided by our 15, which equals 0.3556 amps. And if we wanted to check, we just do the same again for the 31, and they should total 0.533. So let's do it again. So if we go 5.333 divided by 30 equals, and we get 0.1778. And if we add them both together, plus 0.1778 plus 0.3556 equals 0.5333. So there we're correct. So that's our total amperage that we've worked out that's split in. So happy with that one. Now, moving on to the next one, calculate the energy dissipated by the 35 ohm resistor in 1 minute. Well, energy equals VIT. So looking at the 30 ohm resistor, we've got V equals 5.333 times our I value, well we calculated that down here, times 0.1778, and times our time, which is 1 minute, which gives us 60 seconds. So 5.333 times 0.1778 times 60 equals, and we get 5.69 joules. Now, the final question asks us, if the 30 ohm resistor is removed, will the current measured at the ammeter increase or decrease? Well, we know that the current equals I equals V over R. Okay, so if we currently have 10 ohm resistance with these two connected in parallel. If we remove the 30, we're left with 15 ohms, which gives us a total resistance of 50 ohms. So the total resistance increases. So if that increases, the amperage will go down. So we will have less.